what, Charlie?
1 over x squared?
1 over x squared. There you go. Okay? So let's step it up a bit. Here we go, Charlie. Now don't get scared. I like to refer to this as my attitude adjustment problem. Anyway, let's go on here. Okay, Charlie, let's just write everything out. Okay, Charlie, how many x's are on top?
3.
That's right. How many y's on top?
4.
And how many z's on top?
That would be 5.
Okay, write them all out. Oh, wait a minute. How many x's are on the bottom?
5.
And how many y's on the bottom?
2.
And how many z's?
7.
Okay, Charlie, go ahead and write those out. I'll write them out for you. There you go. Okay. You got them done, Charlie? Yeah, you better have them done. Anyway, let's move on here. Let's start canceling some things out now. Charlie, how many x's can we cancel out? We have 3 x's on top, 5 x's on the bottom, so we can only cancel how many x's out?
3.
That's right, 3 of them. Okay, so it looks like that's going to leave us with 2 on the bottom. Let's go to the y's. Okay, how many y's can we cancel out, Charlie? Remember, we have 4 y's on top and 2 y's on the bottom, so we can only cancel how many y's out?
2.
2. We can't cancel more than 2 because we only have 2 on the bottom. So it appears that it'll leave us with 2 y's on the top. Now let's go to the z's, Charlie. How many z's can we cancel out?
5.
5, that's right, because we only have 5 on the top. So that appears to leave us with 2 z's on the bottom. So we'll go ahead and box those for you there. Okay. So there we see it. We have 2 y's on top, we have 2 x's on the bottom, and 2 z's on the bottom. So Charlie, how do we write y times y?
Y squared.
That's right. How do we write x times x?
X squared.
And how do we write z times z?
Z squared.
Very nice, Charlie. So we're going to write our final answer there. Y squared over x squared times z squared. Very nice there. So let's go back and look at the rules for exponents though. Okay. Since we're dividing here, same basis, we're going to subtract the exponent. So here we go. We have x cubed being divided by x to the 5th, which means we have x to the 3 subtract 5. Then we get to the y's here. Y to the 4th over y squared means y to the 4 minus 2 power. And we bring it home with the z. Z to the 5th over z to the 7th is z to the 5 subtract 7. And so when you do your basic arithmetic, 3 subtract 5, I hope you didn't do the calculator for that, you should get this. X to the negative 2, y to the positive 2, and z to the negative 2. Now, if we look at our result, we see that, hey, that x to the negative 2 times y squared times z to the minus 2, negative 2, must be the same as our answer before, and there we go. Y squared over x squared times z squared, okay? And again, so with those negative exponents, what actually happens when you take it to the denominator, the exponent becomes positive. We'll talk a little bit about that in a few minutes here. So, let's keep going. Oh, what fun. Actually, let's talk about negative exponents right now. Yeah, we get Charlie up to speed here. Okay, let's look at our result here. We have x to the negative 2, y squared, z to the negative 2, and we found that, look at the y squared up there, Charlie. That is a positive exponent. We always want to write our answer with positive exponents in this class. Remember, we're in college now. This is the big time. So we don't write negative exponents. We write our answers, our solutions, with positive exponents. So here we go. Okay, Charlie, let's start with the x to the negative 2. We'll put a little bar here because we're going to have a rational expression, a fraction for our answer. X to the minus 2. To make that exponent positive, we have to do what, Charlie?
Bring it to the bottom.
Bring it to the bottom. There you go. Now, how about the y's?
Leave it there.
Okay, the y squared is already positive, so we're going to leave that on top. Now, the z to the minus 2, we need to take that to the what?
To the bottom.
To the bottom, and there was our answer. Y squared over x squared over z squared. Oh, what fun! Let's go do another one. Okay, here we go. This time we have y to the negative 1 over x to the 3rd, z to the negative 4th. Okay, Charlie, what do we do with that x? X to the 3rd. Do we have to move it?
No.
No, that stays there, right on the bottom. Okay, how about that y to the negative 1? That's on top. It's a negative power, negative exponent, so we're going to do what?
Take it to the bottom.
We're going to bring it down to the bottom, and it becomes y to the positive 1 power. Okay, and then how about the z to the negative 4th? That's already on the bottom, so we need to take that to where, Charlie?
To the top.
To the top there. and write it as z to the 4th. Okay. Well, notice we have our answer is z to the 4th over x cubed y to the 1st. Notice y to the 1st power is written with an exponent as a 1. You're not required to write that. Y to the 1st power simply means you have y. That's all you have to write. So, okay, let's go to another one here. Let's use some different variables, a, b, and c. Okay, Charlie, here. Notice with this one, all of the exponents are negative, so we're going to have to move things around from the top to the bottom, bottom to top, all around like that. Let's start with the a. Okay, Charlie, we have a to the negative 5. We're going to take that to the what, Charlie?
To the bottom.
To the bottom, okay? Now, how about that b? It's on the bottom, so we're going to take it to the
top.
Top, there you go. And the c is on the bottom, has a negative exponent, so we're going to take it to the top. There you go, right there. And there's our answer, b to the 6th times c to the 3rd over a to the 5th power. This is just too much fun. Okay, let's do another one here. Let's work with some exponents here. Let's start with this problem, x squared times x cubed. Now, the rules say when you're multiplying when you're multiplying something with the same base, you add the exponents. But let's talk about why that is. Realize here, x squared times x cubed. Remember, x squared means x times x. X cubed means x times x times x. So I want you to realize, basically you have 5x's being multiplied. And we don't write 5x's being multiplied that way. That's where we use the exponent. And so what's our answer, Charlie?
X to the 5th.
X to the 5th. Very good here. Okay, so we're just kind of going over some problems where students tend to make mistakes, especially him over there. Okay, so let's look at this problem here. 2x plus 3x. This is like saying if you have 2 apples and somebody gives you 3 more apples, how many apples do you have? Charlie?
5 apples.
5 apples. It's the same problem. Watch. Remember, what does 2x mean, Charlie?
X plus x.
X plus x, very good. And we're going to add another 3x, which means
X plus x plus
x
x.
plus x plus x. Now, how do we write x plus x plus x plus x plus x?
5x.
5x, that's right. So that is your answer, 5x. So 2x's plus 3 more x's gives you 5x's. Very nice. Okay, let's go to another one here. Now let's deal with x squared. Now don't get scared. Everybody gets confused. This is like combining like terms. Remember, once you define that you have like terms, all you do is look at the coefficients. And the coefficients are basically the number. It's basically an arithmetic problem. In that, what's 2 plus 3, Charlie?
5.
5. So 2 apples plus 3 apples is 5 apples. 2 x's plus 3 x's gives you how many x's, Charlie?
5 x's.
5 x's, and here we have 2x squared. Now, Charlie, what does 2x squared mean?
X squared
X
plus
squared
x
plus
squared.
x squared. Okay, good. Now we're going to add how many more x squareds?
3 more.
3 more. So you see we have x squared plus x squared. Take a break. Now add 3 more x squareds. X squared plus x squared plus x squared gives you how many x squareds, Charlie?
5 of them.
5 of them, that's right. So your answer is 5x squared. So it's just like 2 apples plus 3 apples gives you 5 apples, except you have x squareds here, okay? Okay.